Okay, so welcome to the control room for the carbon capture process at Imperial College London. We're currently in the main control room for the equipment that you can see through the window just behind me. This is a pilot scale carbon capture process that replicates the types of system that would be used for removing carbon dioxide from the flue gases of a coal or a gas-fired power station, for example. In terms of scale, this is designed to process around 500 tons per year of carbon dioxide. It's equivalent in height to around 3 double-decker buses stacked on top of each other. In terms of the scale of the process, very roughly each person has a carbon footprint of 10 tons per person per year. So this would process equivalent to the carbon dioxide footprint for 50 people.
Hello and welcome to the Department of Chemical Engineering. I'm Clive Rodgers, I'm marketing consultant for the department and I organise the summer schools every year. This year we have over 65 students from America and we also have 20 from China. And also, for you the viewer, we have 40 from Korea. So what do we do here? We provide an active syllabus of laboratory experiments based on our own MEng program, and we also provide a series of sessions here in the carbon capture pilot plant, which is again based on our own undergrads MEng program. You will start off with a gentle introduction to carbon capture theory. You will then move on to learning how to walk around the carbon capture pilot plant using a map, which is called the PNID, which is a piping and instrumentation diagram. You will learn how to recognize the symbols and how to locate them on the diagram and locate them in real life. We have over 250 such instruments, both analog and digital. They are cutting edge in a lot of cases because we have a unique partnership with ABB who guarantee for the next 10 years to give us the most up-to-date cutting edge technology, which they use here as a showroom for their clients, and we also get the advantage of using them ourselves. They have been in a pilot plant. Okay, so that is quite unique. And this pilot plant also is probably one of the largest educational pilot plants in the world. We don't know of any other this size.
I believe so. Yeah.
This is over 4 stories high, so that's equivalent of 4 London Deckers. The department was willing to demolish its chemical engineering department and build a carbon capture pilot plant and then rebuild the department around it. So the carbon capture pilot plant is truly at the heart of all teaching at Imperial in the chemical engineering department.
So would you talk about the real background of why the carbon capture was selected as a pilot plant? I think
That's
in
more
terms of
Colin.
maintenance of pilot plant.
Firstly, we needed a facility that was suitable for being in the middle of a chemical engineering building in the middle of quite a busy part of London. So we had to think about the operating conditions that we could run the process at. We also wanted to continue some of the natural enthusiasm that our students had for looking at environmental issues.
Okay.
The other key reason for choosing this particular process is actually it combines lots of different aspects of core parts of the curriculum for chemical engineering. So
no problem in dealing with the waste or output of from operating pilot plant.
In this particular case, the facility is a closed loop system. So actually, what we do is the carbon dioxide and nitrogen that we feed in, which represents our flue gas, we can vary the proportions of that, so we can replicate near to the flue gas from a coal-fired power station, for example. So that would be around 20% of carbon dioxide in the gas stream. All the way through to something nearer to a gas-fired flue gas stream, which would be nearer to 5% by volume.
Okay.
So we can feed in different mixtures, replicate different types of process. We then separate them as you would on a standard carbon capture plant. In our particular case, though, the carbon dioxide that we release, we actually cycle back around to the start again. So we keep the gases within the process.
The Imperial College, historically very famous in terms of giving students a practical curriculum. You know,
Absolutely.
a long time ago there was the power plant, right? The analog system.
We believe in hands-on teaching here, so that when our students are fully fledged chemical engineers, they don't have to work out how to apply their theory. They've already got that. So the American students, when they come here, they learn only theory. Okay, so for instance, Cornell's laboratory is half the size of this room.
Do you have a license for this pilot plant education system? License? I'm thinking about the future. You know, license.
We don't actually need a license, but we do.
I mean, like for example, from a country, a university in foreign country, they are eager to have by benchmarking this pilot plant, they want to have the pilot plant by benchmarking this pilot plant for their students, and then you might from start to design. They need to design.
You mean a copyright?
Pilot plant. I mean, like an EPC.
We are
License,
at this moment in advanced talks in Mexico of building another educational facility,
Uh-huh.
almost a replica of this one.
Ah.
And
Really?